So we finished with addition. Now let's move to the second type of reaction that we will see in chemistry 30 organic, that is known as the substitution. Okay, what is happening in the substitution? One of the hydrogens from an alkane is replaced, is substituted with a halogen. Okay, and then this way, what it is produced is an derivative, hydrocarbon derivative, and an acid. So what do we see in the case when we have the substitution? The name is saying it. It is one of the hydrogens is replaced with a halide. So when we have, let's suppose, this as a reaction. And now we are dealing only with a single bonded here, okay? So alkane plus halide will give you derivative plus HX, where X is the either Br, I, or F, or Cl, Br2. So one of them, let's say this one here, is replaced with one of the bromine, and then it is forming CCC Br here, and then they are all H's. And then this H that was here is bonded with the left bromine, and it is forming HBr. So what do you have on this case, on the substitution? You have two products. In a difference with addition, and here you have two products. One of the products is organic halide, and the other one is H halide, X. So it's either HBr, HCl, HF, or HI. Okay? So this is the very first type of substitution reaction. I will write it in words so that you can have it, and then we'll move on to the second type of substitute. Okay, so this is the very first way that the substitution is happening. And hydrogen is replaced from the alkane, meaning single bonded. This is what we will see in chemistry 30, is reacting with halogen gas, whatever is on group 17. And then one of those is going to replace the H, and the H is combined with whatever is left from halogen to form the acid. That can be HBr, HCl, HF, or HI. The second type is when an alcohol, remember what alcohol is? It has the hydroxyl in the chain. So instead of one H in the chain, then we have an OH. An alcohol is reacting with an HX. So HX is one of those. Okay, is reacting with an HX. And then what the OH is substituted with the halogen. And then we have an organic halide and water formed. So let's suppose that we have this. OH here, okay? And it is reacting with HX. So let's suppose that is hydrochloric acid. So now what is happening, this hydroxyl is replaced with the halogen, okay? Then what do we have here is C, 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 and here we have Cl. And now, as a result of this, what do we have is HOH, which is nothing but water. So when we have an alcohol reacting with an HX, alcohol reacts with, this is the second type of the substitution. The hydroxyl is replaced by the X, the halogen part, to form organic halide and water. Okay? Makes sense, the second type? So still at the end, same as this one here, we have an organic halide. But on the first case, we had an HX, so either an HBr, HF, HCl, or HI. And on the second case, this HX is part of the reactants, okay? And then as a product, what do we have? We have an organic halide and water. So as the third type of substitution, it's an halide is reacting with OH minus. So the third type is the organic halide is reacting with an OH. But you cannot, as I have said so many times, that it's not that we have a bucket of whatever ions and then we are boom throwing it there. It is in the form of bases. Okay, so it's reacting with OH minus, which you cannot have it in as a just OH minus, but you will have this in the form of a base in aqua solution, because what is happening in the aqua solution is dissociation. So Na plus and OH minus in aqua solution. So this is what you will see in the reaction is an organic halide plus a base, that in this case is sodium hydroxide. And then what do you have in the reactant part to produce alcohol to produce alcohol and the halogen ion. Why they were the most important for halogen ion, which again may be as a base, but being in aqua solution, then what you will see it's like ions of it. So when we see it as an organic halide reacting with just OH minus, then we will have the ions on the other side. And this comes even to the conservation law. So if it starts with a negative charge, then on the product you cannot have a positive charge or a neutral. The same charge that you have as a total for the reactants, you should have it for the products as well. So let's suppose that we have something like this. So 1 bromo propyl propane is reacting with OH minus, which I said that you may see it as OH minus, but often you will see it as a base, as NaOH, or any base of that, especially that is from group 1, anything that is potassium hydroxide or things like that. So now this is replaced by this. So this is kind of taking the place here. And then as a product, what do you have is an alcohol. And what is left, since it is kicked out, this Br is kicked out of the chain, and then what do you see is the ion here. If this was an AOH, then this will be an ABr without the negative one. Understood those 3 types of substitution reaction that you will see on chemistry 30? Every time that this is happening, it is happening in the presence of something that is like it's promoting that kind of reaction. So it is not that it's happening out of the blue, but you have either a catalyst, a light, high pressure, or things like that. Okay, so let's see now. When we have cyclopentane reacting with iodine, what it is producing. Okay, so cyclopentane is something like this: 1, 2, 3, 4, 5. Okay, and it's reacting with iodine in the presence of UV light. So here you have UV. And then let's see the mechanism that is happening. Keep in mind that what do you have here? It's, those vertices of the cyclopentane. So cyclopentane reacting with iodine to produce what? Let's see the mechanism that is happening here. So one of those hydrogens that is here, on the vertices you have carbons, and one of those hydrogen is replaced by one of the iodines. Okay, and then this hydrogen that you are kicking out, quote unquote, that the iodine is kicking out, the hydrogen here is going to be connected with HI. So what you have here is a cyclopentane that has an iodine here, and you have an HI. So this is the first type of substitution. In the naming, this will be iodo cyclopentane plus hydrogen iodide. Make sense? What is happening here? This hydroxyl group is, quote unquote, kicked out by the chlorine. So chlorine is saying, move over, and I will come here. So then you will have a Cl organic halide here. And on the other hand, what is happening with OH and hydrogen, they are forming HOH, which is nothing but water. So here you have the organic halide and water formed. Okay, and then when we have the NOH, as a presence in the solution, what you will see is that OH, NOH and OH minus, so NaOH in aqua solution, actually what you have is Na plus and OH minus. So now the hydroxyl is replacing one of the hydrogens to form alcohol. Okay, this is the substitution. There are 3 types on it. So the first one, when you are reacting with halogen, whatever is on group 17 as the as a gas, so you will have F2Cl2Br2 I2, one of those. And then what you have is organic halide and HX, which is the H, and the X is whatever is left from that that group 17. Then the second one is when an alcohol is reacting with an HX, and when we have that the OH present that is forming the alcohol. So OH is, it's kicking out one of the hydrogens and then it's forming an alcohol. Keep in mind that in substitution, what we are dealing with is just, this is for chemistry 30, just alkane, so just single bonded aliphatics. So the aliphatics, it's on the first and the second type is forming organic halide, and on the third one is forming the alcohol. Okay, makes sense?